So what I'm going to do, haven't done a live stream in a while, so I thought I'd go ahead and do it. It's a topic I've covered many times before on the normal edited videos, but had a little time. I thought I'd just go over it one more time. So I'm still in the process of perfecting this wheel pant. Now I've got wheel pants here. This is I had a video where I made the plug. Excuse me. I had a video where I made the plug, and I might even had a video on the mold. So anyway, so this is a wheel pant. I made the left and right half, and then I seam taped it right through the center. Okay, by doing that, it comes together pretty easy, but there's like little teeny disparities. We're only talking 5/10 thousandths or maybe even less. So then you go back and you sand a little bit and you put a little bit of filler on the seam, and it didn't really affect the weight too much, maybe another gram or so. You know, it's just like a super skin coat. What that does, it just slows the process down. Just more work. And then I made this mold, and I've got a couple of them here. I'm going to lay up these parts, but I put the little pegs in here. You call them key pins or pegs or whatever, but basically it allows these molds to come together, and when the molds come together, it automatically aligns. So if you lay up both halves and you close the mold, technically you could go back inside and then put your seam tape in there while the actual wheel pant is being held together in a line. And Kevin Matney has done a lot of videos on his Quickie 500s, and he's talked about wet lap. And what he's talking about there with a wet lap is where you don't actually apply the tape. You bring the fiberglass up over the edge of the mold and you wet it out. And then the other mold, you trim it flush. And then you sort of squeeze the fiberglass inside the mold that's sticking out, and then you close the mold. And then once you do that, you can go through there with an acid brush and you can just sort of lay it back over, and that eliminates adding tape after the fact. The tape is actually, you know, part of the fiberglass that comes up over the edge. And that's one way of doing it. And there's no right or wrong way. There's some ways that are you're going to have to work with. It depends on the part geometry. You know, some molds you're not able to get to the inside. Okay, so here's another little thing I came up with. Basically, you just take a mold, an existing mold, and preferably without the pins, you know, just a flat one. And I've got a mold in the warming box over there that doesn't have these. As I laid up a wheel pant half, which was this here, and instead of having a knife edge and then trimming it flush, what I did is I made this plate that lays over the top like this. It's Lexan plexiglass, and it lays flush against the face of the mold. And then when I lay up the fiberglass, I trim it flush, you know, with the edge while it's still wet. And then I place this plate. Now the plate overhangs onto the inside of the mold. And what that allows me to do is form a lip underneath this plastic plate. So in effect, what happens is the fiberglass goes through the mold, and it comes up and it rolls around to this flange. So you create a flange. So this is what I did. And it's got a miniature flange. It doesn't take much because it's so small. But I built a little flange with the plate. And part of the flange is composed of the little carbon fiber toe. I just laid that in there. The idea behind this little flange is when you glue the two halves together, they come together really accurate and you don't actually need any tape. That's the thinking. So the glue surface on this flange will be enough to hold the two halves together. And it's probably 1/32 of an inch, 1/16 up here, 1/16 back here. So you've got a decent glue surface, okay? Now obviously, if you have a bigger part like a wing or a fuselage or whatever you're doing, you want a bigger flange. And to get that, you'd have to shrink the plastic plate so your glass and carbon, it comes up and then rolls over, and this bottom of the plate actually becomes part of your mold. Now to hold this plate on top of the mold, I have these little clamps or paper clips. These here. So this was laid on top, and I ran these clips around the perimeter. And it's really important that you actually hold this plastic plate flat to your mold surface flange, because you want that to be a parting plane, so you want that to be flat. Now this is 1/8 inch, I think. It might be metric, but basically it's 1/8 for me. This was sort of overkill. It was hard to machine this. I cut it on a bandsaw and sanded the edge. And when it came time to actually open the center up for the actual part, it was sort of a dirty, messy process. I had to actually go in there with a cut-off wheel and basically melt the groove. And then I took a Dremel carbide burr and smoothed it down. So that's where I'm at on that. Let's see here. Hey Steve. Hey Brent. Nice to see you guys. Like a woodpecker in a petrified forest out here on these wheel pants. It's easy to make wheel pants. Obviously this. Where it gets hard is when you got to make them quick and efficient. So that's where I'm at. It's going to happen. It's coming together. So I'm going to go over just laying it up. Now here's a bag of pants. These are a different size. Basically, they're smaller. I'm not sure. I've got so many molds for wheel pants. They're different shapes and sizes. This one is too heavy. It's going to be an RC pant. I got some RC planes. Gotta put these on. And when I mean heavy, let's see. Here's one that's fairly light. Let's see, what is this one? This one, okay, this wheel pant is about 9.6 grams. So I don't know, it'd be like a 40 size classic airplane type thing. So 18 grams a pair. This big heavy one, which I knew was heavy going in, yeah, that thing is way up there, probably, let's see, like 20, 21 or 22 grams. I laid this thing up super heavy. I just started out with like bulk cloth. I knew what I was going to do with it for the RC job. Then the RC plane is dragging it through the grass and banging it down on the grass runway. But yeah, you can get these things down to, well, this was a little over 9 grams. And it's ready for paint, basically. these wheel pants here, it's more like a full-size 60 size stunner. It was copied off Steve Busso's plan, the Kestrel, I think, the Zap machine. But you can see, you know, it's a little bit bigger wheel pant. Let's see, this one's still a little heavy. I think it's a lot heavy. So you're looking at, yeah, you're looking at 14 grams. Now, which basically one set of wheel pants is an ounce. So let's just say, here's the halves without the seam tape. So I'm at 12 grams. So yeah, 14 grams. And that can come down a little bit. But what I found beneficial is 3.2 ounce style 120 glass. It's a very velvety, tight weave. And it's user friendly. It wets out and you don't have to put a surface coating or mold. So, which I'll go over that. Now, going forward, let's just say you got to shave some weight down. Number one, you could shave it down with the flange where you get rid of the seam tape. That would help. And also, instead of going in there with 2 layers of 3.2, you go in there with 1 layer of 3.2 and maybe another 3/4 ounce. And that would save you a little weight. So I'm getting real close where I need to be. So let's mix up some resin. I'm going to mix up HTR 250 and this HT 386. So the HT 386, they've got 2 versions. They've got this version, okay, and then they got 386-99. Now what the 99 means, it's a slower cure. And if you're laying up wheel pants, it doesn't matter. This is fine. If you're laying up a wing or a fuselage and you think you need more time, well then you do the 99. HT 386-99. What that does, it gives you a little bit more open time. So let me write this down so I don't mess it up. So I got 3.2 on the tear. Now what I try to do is make it simple. There's the tear weight, 3.2 grams, and I'll put 10 grams in the cup. And then I automatically know once I get 10 grams in the cup, it's 3.3 grams for the curing agent. If I overshoot it, then probably drag some out. Okay, there's my 10 grams. Now in order to get 3.3 grams, what you almost have to do is transfer this into a smaller cup. It's easier to pour 3.3 grams out of a little cup than it is a big bottle. So, So I'll dial this up, 3.3 grams. So, you can watch this gram scale. 5 or 6 drips is like 1/10 of a gram. Yeah, I normally don't live stream that much anymore. Sometimes I think, depending on the subject matter, people like to go through a quick edited video. Besides, if you screw something up, you know, that's it. You're live. It's like turning on the camera. I got a frog in my throat right off the bat and I'm coughing. Now, a couple tips on this style 120, 3.2 ounces. This stuff would be excellent for a fuselage or a wing, in my opinion, without the core material. There's some stuff I'm going to experiment with core material. We'll see. The verdict's out. Just because you get something that's good on one application doesn't mean it's perfect on another. But I got some stuff I'm going to experiment with. We'll see if it works. This style 120, see if you can tell. See how tight the weave is? It's got a very shiny, satiny look to it. And you can tell, you know, you can't hardly even see through it. So that gives you an idea what I'm dealing with, what it looks like. Put the camera down here. Now when it comes time to lay this thing up, basically I just put the resin in the mold first. I'll wipe it in there. These things have already been sprayed with PVA. Now the PVA, depending on your mold finish, here's a mold that was sanded and buffed out. So you can get a pretty good finish with PVA. You got to watch out for dust. But that gives you a really good finish if your mold is sanded and buffed. And I mean like up to 1,000 grit or something. This 302X surface coat buffs out beautiful. Now here's a mold. It's shiny, but it's got just a little bit of grain, and you can see where I didn't buff the mold. I like to get the plug really close with maybe 600, and then I go back afterwards once the mold is made and I sand the mold up to maybe 1,000, 600, 800,000, and then buff it. It's not necessary, but I like to do that. So I'll brush in a light coat of resin on the first coat. Now, a lot of this stuff I'm doing with wheel pants and all this crazy little stuff. what I'm figuring out with the cloth weight and the resin and stuff will be transferred to the whole airplane when I get to that point. Another thing you want to do with a mold like this, it's got real tight cuts in it or bends, like right back here at the tail. The glass will not conform to that sharp bend. And after a while, you sort of figure out what the glass will take as far as distortion, and then you compensate with a little Cabosil and resin, and that bridges the tight spots. All this information is out there. It's nothing new, but one of the things I've noticed when I do these videos, I get, like Steve or Brent will chime in here, but I'd say 60 to 80%, probably around 70 all the time, the people that tune into this channel are people that are they're either not subscribers or they're new. So I'll get an audience, probably 60%, that's never watched before. So you get a handful of people that are the regulars, but then you get other people that just happen to be passing by. So when you make these videos, you're never really sure what to put up. There's all different levels of a skill set or what people want to see. And you'll probably notice if you look at my past videos, there's a ton of videos up that don't have anything to do with balsa wood. And I love balsa wood airplanes, and I build a lot of them. But for right now, this carbon fiber composite stuff is a rabbit hole I'm jumping down to figure out some of the ways of doing it. So here's a dollop of the Cabosil. You can see how thick it got. It's almost like Vaseline now. So I just take it and I just lay a little dollop back here in the back. You got to lay it up wet because if you let that dry and harden, then it's not going to conform. So you just take a little bit oversized here. I cut these probably way too big, but just lay it in there. I try to bias it so I can trim off the big end back here. Start pushing down in the middle. And I just bring it up to the perimeter. You can see the 3.2 style 120, how quick it wets out, and then how quick it conforms. Right up here in the front. Now it's not going to be completely saturated in some spots, but you got to go back and add a little resin. So once I get it stuck down in the mold, then I start getting rid of all the extra that I don't need. So I'll go around the perimeter. Otherwise, if you have too much hanging out, it's hard to get it to lay flat around the edge. You get a lot of distortion. So just trim this back. Now Chris Cox did a series on his airplane, a composite airplane. He used balsa core. Anytime you put a core in there between glass, it's like making an I-beam. It stiffens things up, unbelievable. So I believe in cores, but I'm looking for a core that will actually conform. conform to any shape. Now balsa wood, you really want to bag that down and pre-form your balsa core. So I've got some stuff I'm experimenting with. I'm not going to come out, stick my neck out and say it works yet because I'm not really sure. But one of the things on this PVA, I used to have a Thayer Chandler. It was all stainless steel airbrush. And I could leave PVA in there forever. I mean, as long as it didn't dry out. And it got to where I needed some parts. And I need to fix it, I guess. But anyway, going forward, I bought this Harbor Freight touch-up gun. One of these $10 specials, you know. And it works great, but what had happened is when the cup attaches to the body of the gun, it was just like pot metal or something, and it was rusting in there. And that was without actually storing PVA in it. So what I did, I took some Graco pump armor. So these sprayers that they spray houses with, you know, it's an airless sprayer. It's under pressure. It's you see the construction guys use them. Well, they got some stuff called pump armor, and basically it protects the corrosion and rust or whatever, you know, if you're going to leave a gun sitting for a while. So I put just a little bit of that into the airbrush, and I'd spray it through, and I'd leave just a drop in, you know, leave the insides wet with the pump armor. And so far, knock on wood, it hasn't rusted any of the parts. And I might leave the airbrush or the touch-up gun sitting there probably for, well, I don't know, maybe at least a week or more, sometimes between coats of PVA. Now, at first I wasn't sure if the pump armor was going to affect the PVA, but I make sure that I spray it out of there. So when I load it up with fresh PVA, I go ahead and I don't know, run a little bit of PVA through there to get rid of the pump armor residue if there's any in there. And it hasn't affected the PVA any, so that's a little tip. I'll show you the bottle here in a minute. I'll go over there and get it. So I'll make sure, sometimes I'll put in just a little bit more resin than I need, because I'll go back with some paper towel and I'll smash this down a little bit and blot out the excess. But a couple weeks ago I tried some of that 386-99 and it worked out really well. It does have a longer open time. So right here at the back, you can see basically the little glob of Cabosil. You know, it's conforming to that little area. It allows the glass to bridge up over the sharp corner. And when you start making a part, you're probably going to make one or two parts to figure out what you need as far as glass content, rigidity, how it's all going to go together, where the points are at that are going to give you fits. One of the things Brent talked about, inexpensive way of actually coming up with some of these parts. He mentioned trying a thing where you have, instead of fiberglass on a wing, the paper, brown craft paper. And there was a gentleman that did a video with that process. And I think it turned out pretty good. It might have been too heavy for a competitive stunner. But he used white glue. And I think he was on the right track. But I think going forward, if you experiment with, instead of the white glue, with a resin, and then try to use something like a lighter paper maybe. Now what I'm doing right here, I'm adding 2 little patches of glass, and that's where the axle comes through the side, and I put them on both sides of the pant. It's like reinforcement right in this area. Now if you look in there, you can see how it's still too shiny. You see the gloss in there? Frog, how you doing? How you doing, guy? So something this small and this thin, it's easy to get the resin out. And here's how I do that. Get some paper towel. And this is the magic that sort of helps out. I'll go through there and I'll blot. And it compacts the glass down tight. And it also sucks up all the excess resin. Now you got to be sort of careful. I mean, you don't want to start scooting this around too much. But I'd rather put just a little bit too much in there and then take it back out to get the right amount. And you want it to look like it's wet, but you don't want a gloss. Anytime you have a gloss, that means you just got too much resin floating on top of the glass, and that's not going to do you any good. Just going to add weight. Now, how much weight I'm getting out of here, I don't know, but every little bit counts. There were some guys that were doing some kind of wing. They were glassing some wing sheeting. They had toilet paper, and they take a toilet paper roll and they roll it across the wing to sop up all the extra resin. It's probably like a Z-epoxy. So see if we can get a better look at that. See how it's sort of a satin look? It's not a shiny look. That's what you're really shooting for. So let's just say you're building a fuselage or something. You can go ahead and put carbon tow in there. You can do a lot of different things to stiffen it up. You can run tow, or something like this. If you have, of course, like up here where the axle goes, I just put a couple glass doublers in there. And if you get a bubble in there, basically I find that if you stipple it, it's what you want to do. And you want to bring the resin up over out of the mold into this glass on the perimeter. That makes it easier to cut it. It gives you a hard surface to actually cut. Now, another thing you'll notice when you do this, if you start doing this a lot and you're trying to stretch out the cup of resin, as the time ticks off, it gets gooier and gooier, and then you end up fighting a lot of strands. little fiberglass strands that are in there. Starts getting sticky. The 386 curing agent, it goes fairly quick. I can do, with 10 grams, I can do 3 halves, and then I got to mix up another batch. And what I try to do, I have other things sitting around like a pinhole here or there. I'll take the extra resin that I have and I'll use it for something else laying around. I try to keep some stuff sitting there that I can actually use that resin for. And of course, it always helps to have all your glass cut. You don't want to be cutting glass while you're filling the mold, at least if you can help it. I don't know if it's a magic brush or not, but I'll tell you what, guy, with these acid brushes, I never had the problem before, but I take them and clean them with acetone now. I get a lot of dirt out of them and crud. I was having trouble contaminating the actual part because of I think some of these acid brushes even had a release in there. They were giving me trouble. On the landing gear, I put a surface coat in there and let it be-stage, and when I came back to do the actual layup on top of the surface, or on the surface coat, it was beading up on me. And then I kept laying it up. It's too late to do anything but now, but kept laying up, and then it would delaminate, not the actual part, but the surface coat. And when I used to make them all the time, I never had that trouble. So basically, I had two things that were different than I used to. One of them was the cup, and I wasn't sure if they put some kind of release or silicone in the manufacturing process of these little plastic cups. But I traced it to the brush. The acid brush had a bunch of gunk in it. And when you'd wash it out with acetone, it would be like a light brown film. A bunch of dirt would come out of it. So when I started acetoning, cleaning the brush, that problem went away. That just goes to show you there's one little variable can screw you up. So this is the first layer, and I'm not worried about, keeping the what I want to say, keeping the resin to a minimum, because I know I'm going back with another layer of glass. So the layer of glass I'm going to lay on top of this is going to soak this up, and then I'm going to blot the top layer with some paper towel. In one of my previous videos, I laid up a RC fuselage. I'm about ready to start carving a plug for a control line fuselage. See what kind of results I can get with that. Try to get without no balsa wood in it. So from when I mixed to right now, this resin is getting thicker, and it's still workable, but it takes a little bit more pressure to get it to wet out. So it goes relatively fast. I mean, laying these things up. Where you get into the time is the actual trimming, and you have to join the two halves. So I'm going to make these molds to where I can get into the inside. I'm going to have an exit point where I can get inside to put the tape or the wet lap. And I'm also, like I said at the beginning of the video, I'm going to experiment on the flange, that flange method. Sometimes when you get little gobs of glass in the mold, they're floating around, you're better off just brushing them in and leaving them. Those little fuzzies. Try to stipple this down pretty good. One of the amazing things with this 3.2 style 120 is you can get this in the mold without putting a surface coat in there. And I don't mean a wet surface coat like I did, but sometimes they'd brush in a really fine coat and then let it be stage. This stuff, for the most part, it's like super pinhole free. If you pay attention to what you're doing, you'll have really good luck with it. And the secret is, of course, the right viscosity of the resin. Now, if I'd make this wheel pant with EPON 815 and 33% per hundredweight on this 33 or 386, you get a lot thinner resin and it would even go quicker. And you'd still end up with really good properties. Now, West Systems is good, but you got to watch it. It starts B-staging or kicking off even quicker than what I've got. But the HT386 is a fairly reactive resin curing agent. Now, I think Joe Daly did HTR212, which is like the 250, it's just a lower viscosity, so you even get a better wet out with the 212. And nearly, maybe not exactly, but almost as good of heat deflection temperature. And I think you can get that, I'm not sure where he got his, but I think you can get it Aircraft Spruce and Specialty. They'll have it. I'm not sure if Wix gets into the resin services line. I know Aircraft Spruce will get into some of them, or of course Direct. Just call them up. If you Google resin services up here in Michigan, they come up. And then you can get online and you can start looking at all the properties. They have, I think, PDFs or, you know, information online of all the properties of the stuff they sell. That one fuzzy in there is bugging me. Get that out of there. So back here in this little cutout, little flange tight spot, takes extra attention. Got to make sure that's all pecked down. That's about it. Once you get to that stage, start blotting. Now, if I wasn't filming, I'd probably go ahead and try to rush another one and get 3 done. 3 halves, but I think I'm going to be good with these 2. I'm going to talk about a couple other things before I get off here. Not sure how many people are watching. I can't keep track of how many are on here, but They come back later. They can pick it up. Now, I know Robert, he likes to stay within the magic hour. And me, I don't care. I just keep on talking. It don't matter to me. So this layup, 2 layers plus 2 on the axle area, gives you a really good part. It's a compromise, you know. You want it strong enough to where everything's staying together and it's got integrity, but then you got to have it light. And of course, then there's carbon if you ever go that route. And to be honest with you, I think if it came to carbon, you could probably save weight, but we're only talking a few grams. And then if you go carbon and you're not careful when you lay it up, heck, you could lay up carbon. A bad carbon layup is probably heavier than a good glass, you know, if you're paying attention to what you're doing. So, and then not to mention the cost, you know. Yeah, I'm just getting the gloss out of there, making it nice and satiny. I try to wipe this down so the glass is tight against the corner of that mold, so I'm not laying on top of all the cabosil in there. Just go through there, really look really close and make sure it's what I want. Sometimes I'll go back 15-20 minutes later and just make sure something didn't pull loose. Usually it doesn't happen on wheel pant, but if you're laying up a fuse or something, and you're really pushing the drapeability of your glass, you gotta pay attention to it. So that's about it. That's how long it takes to lay up 2 halves. So let's see, what else was I going to talk about? There's probably something else. I can't remember what it was. Yeah. This guy in the club, he crashed this airplane. So he's got all these different cracks in it. So I go in here. I've already sanded this. He stripped the paint off of it. He's got it all stripped down. So I'm going to go in here with all my scraps. I got just a little bit of resin. I'm going to fix him up a little bit. Boy, this RC stuff, boy, you can just lather it in there. It don't matter. You ain't worry about shininess. You just load it up. Slap that big old gas motor on here. And usually something like this, a repair, I'll just slap all this glass in there till I run out of resin. And then I'll put the old Bondo on the outside, smooth this sucker down. I'll blast it down with some primer. Make it look like a Toledo showpiece. I don't know what he stripped all the paint off with, but it's nice and clean. Now, I sanded the inside here and roughed it up, but I'm not having any trouble with this resin going down on this glass. He must have cleaned it really well. And of course, I just leave it hanging out. It's not going to matter. I'll trim that after it cures. And really, if you had a control line airplane, it's like Joe Daly did some repairs on his airplane. Same thing. Basically, you just line it up, get it to where it's all aligned, like this crack. You get it to where it's coming together, and then you just go behind it and reinforce it. So remember, you get 4 layers of this 3-2. You got 12-8. So it builds up pretty quick. One guy in the club, I was talking to him about this cloth. He said he didn't like it. I think he had trouble wetting it out. And I think his problem was maybe West System's a little thick and fast. I think he got behind the curve on it all the time. He liked to use more like a boat cloth. Yeah, and there's one little piece of this cow. It's like right here, that little thin wispy. I'll probably go inside later when I get more resin. I'll run a carbon toe right across that. So I'll fix that. But yeah, I just each time I lay up a wheel pan or something, I just save the extra and work on that repair. That's all there is to it. That'll be as good as new. So then I got rid of my 10 grams, and I still got a little Cavasil here. Now that I'm thinking about it, might as well lather a little of this on instead of wasting it. I can use Bondo, but put some of this on there. Now, if you want sandability on a filler, Cavasil or micro balloons. Now, Cavasil or fumed silica. Cavasil is like a trade name. It's nice and smooth and it works good. And you can go with micro balloons. Micro balloons has porosity, of course, because of the balloons, but it sands easy. And then let's just say you need something with a little bit more structure. Let's say these wheel pants with this flange, you know. And if I needed more structure, something a little bit, I'm trying to say, I don't mean structure, but something that's going to hold up a little bit tougher. You put cotton flocks in it. And the cotton flocks is mixed up so tight or so fine that it's almost like fumed silica or micro balloons. It's really ground up fine. But you know, with Cavasil, you can take a epoxy, you know, and crack it easier. With the cotton flocks, those little fibers add strength to it. And then, of course, you have chopped carbon. Another thing I did, let's see, where's the wheel pant? It might be worth mentioning. I was laying these things up where I was gluing them together. And as I'm gluing them together, it's starting out good because the resin is really thin. And after about 2 or 3, the resin gets thicker, and I'm jamming fiberglass cloth down in this little hole, and I'm ending up with a bird's nest of fibers. So I thought, you know, there's got to be a better way right now. So what I did is I took chopped carbon. The chopped carbon is maybe, I don't know, 3/32 or an eighth. I don't know. It's chopped up pretty fine. I mixed it in with the resin to where it's almost like a paste. And then I took it on the brush and I just dabbed the chopped carbon down in there and put it over the seam. So you can see the carbon fiber in there, and that's overkill. I put way too much, but it would probably only take maybe an 1/8 inch wide right over that seam. But the paste with chopped carbon turns into structure, probably more so than the fiberglass strip that you put in there. And it's easier to get in there. So when you actually try to put the fiberglass tape, basically you've got, you know, some of the glass going this way, which adds strength to the seam, and then lengthwise it really doesn't do anything to the seam. With the chopped carbon, you know, with it going all directions, it's probably more structural than the glass cloth, and it's easier to get in the small tight spots. So that worked out good. But once my mold is finished over there, which is a mold that I'm going to use these 2 plates on. I've got a left and a right, and it's without the bumps, and that's what I'm going to use these plates on, and that'll form the flange. And the verdict's still out whether that little flange is going to be enough, but I think it will be. It'll be glued together with the same resin that the wheel pant is made out of. So I think we're going to be all right. So yeah, that's about all I wanted to go through here. I just wanted to waste some time, about an hour, and lay this thing up, show you how long it took. And I'm going to lay up the other 2 here when I turn the camera off. I got 2 more halves for another. I try to do 4 halves. I try to lay them up to where, you know, I got a pair. And then what I do, once I pull all the shells out, throw them in a bag and number them. So if you make this mold left and right off the plug, and then you make the parts out of the mold, you number the parts like A, B, C, D, or whatever. That way you've got matching halves. And, just in case the parting board plug was different on one than the other. Try to keep it all in alignment. And I just put them in here. These are all my halves. See, I've got some other stuff over here. Trying to remember what I've got. Let's see. I used to do a lot of RC stuff, This is a 20% extra 300. This is a substantial mold. I mean, I made this with a ton of tooling dough. Drive a car over this thing. And this was my plug. It's a tooling board. Extra 300. That might have been the Midwest kit. Let's see. Here's something that this says Sparky Copy. He brought over his wheel pant from a crashed airplane. There's the mold for that. Matter of fact, it sort of looks like what I've got in the bag. I'd have to double check it. This is a Funky 40. That's a little RC airplane. These things are pods for miniature RC fuselages. Little pods. Basically, it's the same construction technique as a wheel pant. I can tell that the actual plug is in there. Let's see what it is. Yeah, oh, it's not the plug, it's the part. So these little pods I was making for an RC plane. There's a wing saddle. There's a mold for that. Who knows what this is? One of the things I've done, it's a bad habit. You make these molds and you don't label them. Not label what it is, but it's important to label what the mold is made out of so you know if it's high temp or not. So yeah, here's another wheel pant. Okay, I forgot I had this thing, but this wheel pant was, this is only half I made. So what I did is I made this half off the plug, and this is all one piece. This is molded into this. And what I've done is I put sheet wax between the two. So instead of vacuum bagging the glass in there, basically I'd lay glass on this, some in here, and then jam them together. And basically this was a male form that would form this. So that would basically form the gear. I mean, form the wheel pant without a vacuum bag. It would be compression molded. I'll have to revisit that and see if it works. And here's sort of a crude one. I'll see what this is. But I can dig all these out. I think when I come to the gnats, I'll see how much of this stuff I can make, whether it be gear, pants. I'll try to just bring it. And I owe people stuff. You know, I'm getting so far behind. I don't owe them anything, but I told them I make stuff. Here's another set of wheel pants. This says West Systems on it. So that's how this mold was made. It's a high temp surface coat, the 320X. It's been polished. So you can make molds just out of regular West Systems. And that's what this is. At least I marked it so I didn't put it in an oven. That's a good deal. Here's some molds that are in between, like a medium. These are a little on the small, narrow side. What I was doing here, I get samples of different resin. This is a room temp surface coat. It was white, and I backed it up with some carbon. Same thing here. It was a white surface coat with carbon back. And here's another one. This I think is gray surface coat with just fiberglass on the back end of it. So, and I've got all the plugs. Every one of these molds, I've got the original plug somewhere so I can make more molds. Edge 540. And this might have been a Bob Godfrey aerobatic plane. That's a big old wheel pant. Here's a Citabria. This was a Balsa USA Citabria. They had vacuum formed plastic wheel pants. And this is one I made for fiberglass. My brother-in-law built that. And some of these wheel pants are so generic looking, you know, you could put them on anything. Alright, so that's about all the yakking I wanted to do. And I'll get off here and I'll finish these other halves. Let me see what I got. I think everybody just chimed in here. Let's see. Okay, Len. I'm not sure why I don't get your notifications. Yeah, you know, maybe, heck, I don't know. I know with this channel, it's one of these things where I don't take it real serious. You know, I'm not monetized. You know, I throw stuff out there, and it's just to help people. Made some pants. Yeah, carbon Kevlar and 4-ounce glass inside Kevlar patches over the axle hole. That would be a great way of doing it. Yes, 4-ounce. Carbon without Kevlar, 2x2 twill ends up stiffer. Yeah, Kevlar isn't very stiff. Nylon and paper towels get excess epoxy. Yeah, so one of the things, talking about vacuum bagging, and it was surprising to me, these bags, I bought a bunch of them, just put parts in it. So when I cut ribs out or stuff or wheel pants, I try to put them in here. One of the things that amazed me, and I did a video the other day, I put, when I made a wheel pant mold, I just stuck the glass in the plug in here, and I bagged it down with this. But this Ziploc, you know, when I zipped this closed, it held the vacuum. And I was prepared to put tacky tape, or, you know, I thought I'd have to come back with a little caulk or something in there to seal it up, but it held. So it's surprising, but the problem is, you know, if you get a different brand, now these are the kind you just squeeze and they seal really well. Now the ones with the slider block, you know, it goes back and forth, I'm not sure, but it could depend on the brand. But yeah, another thing I was talking to Howard Rush, and he was talking about in the oven or something. I said, go to the grocery store and get you the turkey roasting bags, or, you know, they got these crock pot liners where you put in there, or you cook a turkey in this big bag, and they're pretty good size. So if you get tacky tape that's hot, I mean with a high temp, and you get a turkey bag, you know, you just stick your part in there, and you're able to actually cure something under some heat, you know. If you could get it to seal, you could stick it in your oven, and maybe it wouldn't stink up the oven if you held the vacuum good enough. So there's a lot of workarounds. 2 by 2 twill, that'd be pretty. Yeah, as far as me building, it's more like science fair projects out here. And I was telling Robert, I said, I got to get from point A to B. And I mean, point B would be actually flying the airplane. One of the things I want to do, I've got this airplane up there. It's a Cobra. And it was a or Mike Dietrich Cobra. I'll turn this camera around real quick. It's an I-beam, and it sat up on the ceiling forever. And I was going through a bunch of VHS tapes, and I found 2 tapes that are listed building the Cobra. And I didn't remember filming it, but supposedly a VHS tape was 2 hours, so I don't know. I might have close to 4 hours of a video of me putting that thing together. And I can't remember when Mike Dietrich published that in Flying Models, but that's the plans I built that from. So that'll be interesting if I can get that from VHS to digital. And probably scare myself. So anyway, that's fun though. Have a hard time finishing projects. I just like tinkering. And right before I retired, I got to where I had all these little things in my head that I wanted to try. I call them science fair experiments, you know. And when you're dealing with composites, it's like a never-ending list. You can just go on forever. And there's so many things I want to do, but I've got to actually get them finished. Now, there's another thing I want to show you. There's a gentleman, I'm not going to mention his last name, I don't want to put that out there, but he's in Kansas City, and he contacted me. I don't like putting people's names out there, but he contacted me, and he said he had some carbon fiber, and this was in the 90s, I believe. And it's different than anything I've ever seen. What this is he had a big roll of it, and it was surplus from an aerospace manufacturer. I think it was Amoco. And believe it or not, the petroleum companies were in charge of carbon. I mean, it basically starts out as a petroleum. There's 2 types of carbon. There's pan and there's pitch. Now pitch is made from the oil pitch, and then pan is made from a fiber, like a carbon or like a carpet fiber. And it's 1 strand of thin fiber, and they carbonize it. So by handling this stuff, it's probably pan. It went on a stealth fighter, and I think it was Boeing. It says Thurncell, ACSX, and IMG, and you can tell by feeling it. This feels thicker than this, but they weigh the same. Now, he sent this to me as like, okay, what can you do with this? And it's obvious. When you take this stuff, you can laminate it for spar material. It's I'm guessing it's probably only 4 or 5 thousandths thick. So if you glue this and epoxy it over the top of a spar, I mean, this stuff is really, really high modulus. It's I don't know how to describe it. I've handled enough carbon to know that this is at the top tier. I mean, the super high modulus. So I keep looking at this thinking, okay, what can you do with it? Now, you know, if you had enough of this, and I think he does, you wet it out with some high temp epoxy on the back, and you take 2 layers and you laminate it at like 30-40 degrees and on top of some balsa wood or something. So you really can't change the shape of this, because you can wrap it like this, but the other thing is if you took this stuff and you butt it together with tape, you could just wrap it around the wing. I mean, you could have, you know, you could vacuum bag this down on foam. So basically you'd have a monocoque construction and it'd be unidirectional carbon. Well, you'd have a lot of strength this direction and none this way, but if you backed it up with a little glass cloth for modeling, it would be doable. So really neat stuff. I'm going to glue this stuff up on some project. I don't know what I'm going to do with it yet, but it's always fun looking at some of this stuff. I know Howard Rush has bought wholesale from some of these I don't know what you call them, surplus suppliers. Eli Lilly is the big drug company in Indianapolis, and they used to have surplus sales, all the stuff they were getting rid of, and that's where that little lab oven came from. They probably got rid of it because it didn't hold a heat setting within a few degrees. It's good enough for hobby projects, but once it gets old and out of spec, then they get rid of it cheap. So yeah, I love tinkering around with different stuff. There's also some stuff that core material I got at work. They were using it on pre-preg, and I took a little piece and stuck it in a wheel pant instead of the Kevlar. You know, this core material, it's an 1/8 inch and it smashes down. I got it smashed to maybe 3/32, but it's dry, and it conforms. It'll conform to any shape almost. So the way it works, you put it between 2 carbon fiber pre-preg sheets, and then of course you have the extreme crushing, and a little bit of the resin saturates in this core material. And you don't have to use it in one big sheet. You can use it like little ribs. But an autoclave will crush this stuff maybe a 1/16 of an inch or smaller. It super crush. With my little vacuum bag, it only got down to 3/32 from an 1/8 maybe. But it's amazing, you know, how hard and how rigid that one area is. So it could be something to where you use it very sparingly, like in wing saddles or something. So a lot of neat stuff. Okay, guys, if you're still watching, I'm going to jump off here and finish these this other wheel pan half. I want to thank you for coming by and watching, and it's a different topic. I wouldn't say it's boring, but you know, it's a niche in a niche, whatever. It'll be neat though if I get to where all this stuff here is proven and then I finally expand it into the whole airframe. And that's my thinking. You know, all these little projects, when I add them up into one whole airplane, so it'll be the landing gear, the horns, the prop. I like to do videos on making props. I got about a half dozen prop molds. They're old, but refine the molds, do props, and everything. I mean, I want to do everything but the battery and the motor. But it'll be the gear, even the wheels, carbon fiber wheels, and I experimented with certain rubber. I finally found, real quick, and I'll get off here, but I found some Dunham rubber in Greenwood, Indiana. I found this rubber, and it's the exact same thing that they're using on these MPI. John Jordan made these wheels. So it's hard to ask for something when you don't know what you're asking for. So I was out running errands, and I go in there, and they have a bunch of little bins with little samples of all the rubber and silicone mat and everything. And I don't see anything that matches what I'm looking for. So he gave me some samples to try, but you know, they're too heavy. So I was down there running errands again, so I go back in there, and over on the wall, they've got letters cut out. They're like laser cut or machine CNC cut letters that are sticking off the wall out of this foam rubber. And I said, what is that stuff? Because I don't even know what they call it. And he didn't say it was foam rubber. He came up with some kind of fancy name I've never heard of before. He said, oh yeah, that's it. I said, do you have any samples of that? He goes back and he brings out this big roll. Got it right there somewhere. And he brings this out, and you could probably get this in 4x8 sheets. You know, it's. So he just gave me a big coil of it that was scrap. And this is 1/2 inch, I believe, but you know, you can get it in different thicknesses. And so I finally found a source for this stuff. So that's something. And right before John passed away, I was talking to him. He was making these wheels, and they're spectacular wheels. They're machined aluminum. And I said, John, it takes you so long to machine the aluminum. I said, what if I made a mold and I made these inside wheels out of carbon fiber? So the thinking was, you'd have a mold and it would come together, and you'd make a left and right side of this wheel. And then of course it's like this, okay? So then it comes together, and the gap right here is where your tire sits. So, you know, you'd have, this would be your carbon fiber plate, and this would be a plate. And when you glued the two halves together, it would encase the wheel. And then of course you chuck it in a drill press or a lathe, and you could, you know, run a jig around it and make sure everything's perfectly true. So that's where I was at on that, but a lot of neat stuff. So we'll see. Get too sidetracked, but one of these days I'm gonna nail a couple of these things down and make a run. I've already got a pile of bell cranks, small pile of landing gear, and I'm getting a pile of the wheel pants. The other problem is you take the carbon gear and you take the wheel pan and the axle. What I'd love to do is have a whole system where here's the wheel, the axle, the landing gear, and the pant. And it all comes together and it's made for each other. So the pant keys into the carbon leg, you know, where it's not going to rotate. Everything's in alignment. All the hardware, and all you got to do is just bolted to the plane. And Bob came up with this design, Bob Hunt. He's got a trike gear twin, I think it's a twin. So the trike gear, of course the nose wheel, but the actual gear for the two wheels, the main gear is back. The sketch he showed me is probably back towards the trailing edge, maybe not quite that far. I don't know, I have to look at it again. But I was wanting to make that gear. So what I need is the actual span of the fuse, the drop, the profile, the leg. And I sent him one of my gear to look at. It wasn't a gear that I thought would work, but I wanted him to give me the feedback to say, it's too stiff, it's too heavy, it's too light, I don't know. But he did. He told me the properties that were good on it. And obviously the dimensions weren't right, but at least I know what direction to go with it. So yeah, thanks for coming by, and I'll be talking to you guys.